Good morning student, welcome to day 2 of rooftop solar PV installation and maintenance course. Today day 2 course is solar cell, construction of solar cell, characteristics of solar cell. At the end of this lesson, what you are going to know, you shall be able to define what is photovoltaic effect, define what is photovoltaic cell, brief about the construction and working of solar cell, brief about the solar panel, array and PV system, explain the various characteristics of solar cells. First we are going to see about the what is photovoltaic effect. So, what is photovoltaic effect? It is a process of generating electricity from the sunlight is called as photovoltaic effect. The photovoltaic effect was first discovered in 1839 by Edmund Becquerel. How he is find out there is a photovoltaic effect is that there is a process is there. When he is doing experiment, he noted that the voltage of the wet cell increase when its silver plates were exposed to the sunlight. When he is doing some experiment in the wet cell, he accidentally keeping the silver plate of wet cell outside, silver plate is exposed to the sunlight. That time the current carrying capacities, the power of the voltage of the wet cell is increased. From that he find out there is some effect is there that is named as a photovoltaic effect. What is photovoltaic effect? The process of generating electricity from the sunlight or solar energy is called as photovoltaic effect. Next we are going to see what is photovoltaic cell. Photovoltaic cell, it is also called as solar cell. So, what is solar cell? It is a semiconductor device which directly convert the energy of sunlight into electricity through the photovoltaic effect. So, what is a solar cell or what is a photovoltaic cell? It is a semiconductor device, mainly it is a semiconductor device which directly convert the energy of sunlight into electricity through the photovoltaic effect. Then we are going to see the construction of solar cell. In the figure you can see the construction of solar cell. It consists of two layer of semiconductor material. It have two layer of semiconductor material. Already you are knowing what are the two layers. One is a P-type semiconductor, another one is a N-type semiconductors. The top layer, it is also called as emitter layer, is a N-type semiconductors, and the bottom layer, it is also called as base layer. It is a P-type semiconductors. You can see in the figure, there are more than one current collector strip will be there on the top layer of the solar cells. It is used to collect the currents, because the current carrying capacity, that is a current capacity of the single cell is very less. To collect the very few amps current, we want to use more number of current collector strip. It is also called as bus. It is running on the top of the solar cells. It is in the figure you can see there is a symbol of solar cell. So, in the symbols there will be one cell symbol will be there and sunlight symbol will be there. It is a symbol of solar cells. So, now the working of solar cell, how the solar cells are working. When the semiconductor, when the N-type semiconductor and P-type semiconductor join together or placed together, automatically there will be a one PN junction, also called as depletion layer, is developed between the two layers, which does not allow the electrons or current when the solar cells are unexposed to the sunlight. When the solar cells are not placed in the sunlight, the PN junction or the depletion layer which is formed between the N-type semiconductor and P-type semiconductor does not allow the current to flow. So, when the sunlight falls on the PV cells, when already I told, when the sunlight falls on any material, there are three things will happen. One, it may reflect or it may pass through the material, or sometimes some energies are absorbed by the semiconductors. Here also, when the sunlight is falling on the solar cells, some photons are absorbed by the solar cell, which is provides or generate the electricity. Only the absorbed photons are provides or generate the electricities. The photon absorbed by the solar cells or emitter layer produce free electrons and hole pairs. When the photons are absorbed by the solar cells, it generates, it produces free electrons and hole pairs. If the absorbed energy is greater than the energy gap of barrier potential. There will be some depletion layer will be there, it have some energy level. Solar energy absorbed by the solar cell is greater than the barrier potential, then the DC current start to flow from P layer to N layer through the current path if exists. If there is a current path, when the solar energy is greater than the barrier potential of solar cell, then the current will flow through the P layer to N layer. Generally, the top layer of PV cell is coated with anti-reflective material to avoid the loss of energy due to the reflections. When the sunlight is fall, maybe the sunlight may reflect. To avoid the reflection, the top layer of PV cell is coated with anti-reflective material, thus trap more photons so that to discharge more free electrons holes pair when the sunlight falls on the solar cell surface. The bottom layer, when the top layer having a number of current collecting strips or bus to collect the current. However, in the bottom layer is covered by the thin conducting plate, completely thin conducting plate, which is completely covered by the insulating material. The next one is a single PV cell. The size of the single PV cell is 156 mm into 156 mm. It is square in the shape. The single PV cell will give the output of approximately 0.55 volt and 50 milliamps. Next, we are going to see what is solar module, array and solar plant or PV system. If the power generated by a single solar cell is very less, we cannot use the power generated by the solar cell for any useful use. So, what we have to do? We have to connect the solar cells either in series or parallel, then only we will get the more power. If the solar cells are connected in series, to get the higher output, then it is called as solar module or solar panel. Generally, we are selling solar panel, but actual name is a solar module. If the multiple solar panels are connected in series, for example, what is module? If the number of solar cells connected on series, if the number of modules are connected in series, then it is called as solar string. If the number of modules are connected in series, then it is called as solar strings. Similarly, if the multiple number of solar panels are connected in parallel, then it is called as solar array. If the solar panel connected in series, then it is called as solar string. If the solar panel connected in parallel, then it is called as solar array. If the number of strings are connected in parallel, what is string? String means number of solar panels are connected in series. If the number of strings are connected in parallel, then it is called as solar system or solar plant, sometimes PV plant. Next, we are going to see the characteristics of solar panel. So, the basic characteristics is also called as IV characteristics of solar panel. From the IV characteristics, we are going to find out the short circuit current of the solar cell or solar panel, the open circuit voltage, maximum power point of the solar cell, the current at the maximum power point. When the power is maximum, what is the corresponding current, what is the corresponding voltage, and solar energy conversion efficiency. Now, we can see what is the open circuit voltage of the solar cell. The open circuit voltage is denoted by VOC, that is VOC means open circuit voltage. If the terminals of the solar cells are open circuited, then there will be no load, current will be 0, but the voltage will be maximum. If you measure the voltage across the solar panel under open circuit condition, either using multimeter or voltmeter, whatever the voltage is you are getting, it is called as open circuit voltage. Why we have to study? So, open circuit voltage is the maximum voltage which a solar panel can generate. So, this open circuit voltage is a maximum voltage we can measure between the positive and negative terminals of solar panel under open circuit condition, that is no load conditions. So, next one is a short circuit current. What is short circuit current? So, it is if the positive and negative terminals of the solar panels are short circuited, that is called short circuit. Under the short circuit condition, how much current is flowing through the solar panel is called as a short circuit current. It is denoted by ISC. I means current, AC means short circuit, that is ISC. So, why we have to study about the short circuit current? So, short circuit current is the highest current which can deliver by the solar panel or solar sun. It is the highest current. When the solar panels are short circuited, that means if you short circuit the positive and negative terminals of the solar panel, then the current will flow through the solar panel. So, it is the highest current, it is called as short circuit current. So, when the current is highest, that means when we short circuit the solar panel, the voltage will be 0, but current will be maximum. Similarly, when the solar panels are open circuited, the voltage will be maximum, but current will be 0. When the voltage 0, either voltage 0 or current 0, what happens? The power automatically will be 0, because power is multiplication of voltage and current. When the voltage is 0, power is 0. Similarly, under the open circuit current condition, the current will be 0. When the current will be 0, automatically power will be 0. So, under the open circuit condition and short circuit conditions are the extreme conditions of solar panel, we will get the maximum voltage or maximum current, but there will be no electricity generated at this point. At the open circuit voltage point as well as short circuit current point, we will get the maximum current or maximum voltage, but power will be 0. That means there which no electricity generated. If the load is decreases from the short circuit, in the short circuit condition, the current will be maximum. If you want to reduce the current, what we have to do? We have to increase the load. If you decrease the current, what will happen? The voltage drop across the load will increase automatically, then the power also will change. When you change the current and voltage, that is when you change the load, at certain point you will get the maximum power. At one certain point you will get the maximum power. That point is called as maximum power point of the solar panel. That is MPP, maximum power point of the solar panel. How we can find out? We can just load the solar panel and change the load. Automatically what will happen? At each load you will get the corresponding voltage and corresponding current. If you multiply the voltage and current, you will get the power. At certain point you will get the maximum power. That point is called as maximum power points. At the maximum power point, the corresponding value of current and voltage, when the power is maximum, at the maximum power point, there will be some corresponding voltage and current. If you take the current when the power is maximum, it is called as IMP, that is a current as maximum power point. Similarly, at the maximum power point, you will get some corresponding voltage also. That voltage is called as VMP. What is VMP? Voltage at maximum power or peak power. We can say as peak power as well as maximum power. IMP is a current as peak power or current at maximum power. Similarly, VMP is a voltage at maximum power or voltage at a peak power. But what is the maximum power of the solar panel? The maximum power generated by the solar panel is peak power at the standard testing conditions. What is if a solar panel have some specification, some rating. For example, if a solar panel have the capacity of or power rating of 540 watts, that means the solar panel can generate the peak power or maximum power at the standard testing condition. But actually, when we install the solar panel in some location, the actual output of the solar power will change depend upon the temperature and irradiance. Similarly, during the IV characteristics also, the IV characteristics also will change according to the temperature and irradiance. There are two important factors will affect the output of the solar panel. First one, if your temperature, when the temperature increases, what will happen? When the solar panel is installed during a winter time as well as summer time, what will happen? If the temperature increases, the short circuit current may be constant or increases slightly, but the open circuit voltage, the output power will decreases slightly, not more than slightly. So, when the temperature increases, if now it is 25 degrees centigrade, after half an hour or after 1 hour, if the temperature increases to 30 degree, what will happen? When the temperature increases, the short circuit current may be constant or may be increases slightly, but mainly the open circuit voltage and the output power, mainly the output power will decreases slightly. In figure you can see at the 25 degrees centigrade, the output power is denoted by yellow line, it is more. At the 50 degrees centigrade, it is indicated by the orange line is less. Similarly, what will happen if the irradiance is changes? What will happen if the irradiance increases? If the irradiance increases, what will happen? All the three things will increases. Short circuit current, output power increases more, but open circuit voltage increases slightly. All three things are increases. What are the three things? Short circuit current, open circuit voltage, output power, all three are increases. Out of three, the short circuit current, the output power increases more, where the open circuit voltage increase slightly. Next one is a fill factor. What is the fill factor? So it is the ratio between the peak power of the solar panel. What is peak power? That is a maximum output power of the solar panel at the standard testing condition. So it is a ratio between the peak power of the solar panel to the product of open circuit voltage and the short circuit current. So it is a ratio between the peak power to the multiplication of open circuit voltage and short circuit current. This value is almost typically 0.7 to 0.8. Why we want to know that? So this is the active region of the solar panel. When you install the solar panel, even if the solar panel is rated for 500 watts, the active region will be around 70% to 80% only. There is a formula is there to find out the fill factor of the solar panel. The formula is ratio between the peak power divided by the multiplication of open circuit voltage and short circuit current. In the figure, you can see the fill factor, that is the active region of the solar panel. There also some formula is there. Fill factor is a IMP multiplied by VMP divided by the multiplication of short circuit current and open circuit voltage. Finally, the energy conversion efficiency of solar panel. What is the energy conversion efficiency of solar panel? It is the ratio between the peak power of solar panel to the power received from the sun. Generally, the efficiency is the ratio between output power to input power. What is the output power of solar panel? It is denoted in the nameplate detail under specification. It is denoted. It is a maximum power of solar panel. It is written in the label. So it is output of the solar panel. What is the input of the solar panel? How much energy is received from the sun in the solar panel? We have to find out, we have to calculate that one. How to calculate this one? So how to calculate? We have taken the global horizontal irradiance of 1000 watts per meter square. This is a standard value, global horizontal irradiance. It is taken as a 1000 watts per meter square. That means in 1 square meter area, we are getting 1000 watts from the sun. If the solar panel is 3 square meters, then we are getting how much input we are getting in the solar panel? For 1 square meter, we are getting 1000 watts. For 3 square meter, we are getting 3000 watts. This is a input received by the solar panel. So output is a peak power. It is denoted in the solar panel. Input we have to calculate. How to calculate? Multiply 1000 into area of the solar panel in the meters, then you will get the input. Then you can find out the energy conversion efficiency of solar panel, generally input by output. The efficiency is denoted by Greek letter mu and expressed in the percentage. Generally efficiency is expressed in the percentage efficiency. The typical efficiency of the solar panel is around 10 to 25%. Why we have to know about the solar conversion efficiency? Then only we can compare the efficiency of different manufacturers. That is a efficiency, solar conversion efficiency of different manufacturer. Then we can use the solar panel which have the more solar conversion efficiency. The solar conversion efficiency is also called as power to size ratio. How much size of the solar panel, how much power we are getting, it is also called as power to size ratio. So this is the end of our day 2 class. In the class what we have seen, just we can recall. First we are seeing what is photovoltaic effect. First one is a photovoltaic effect. Secondly we are seeing what is photovoltaic cell. What is photovoltaic cell? Then thirdly we are seeing construction and working of solar panel. What is the construction of solar panel? How the solar cells or solar panels are working. Then we have study about the characteristics of solar cells. In characteristics is what we are seeing about the open circuit voltage, we are seeing about the short circuit current, we are seeing about the maximum power point, we are seeing about the current at maximum power point, then voltage at maximum power point, then we are study about the fill factor and energy conversion efficiency. Thank you.